right, so this is going to be a short little video showing how to do an orbital diagram for an ion such as calcium that 2 electrons have left to make it a positive 2. Here's the electron configuration for calcium, and electrons will always leave from the highest energy level first because the Z effect is not as strong. So I'm going to take away, boom, those electrons that live in the 4th energy level as sublevel. Ironically enough, that's going to change this into the electron configuration that's equivalent to argon. It's not going to be argon. It's just going to have an electron configuration to be stable like its closest noble gas. So just like we did before, I start adding my electrons. 2 in the first in the S, 2 in the 2s. I fill up my bedrooms one at a time, first in the P, and when then they're filled, then I backfill so that I have 6 in the 2p. Here's 3s. Same goes with the 3p. So the orbital diagram for calcium with a +2 will be equivalent to the orbital diagram to argon. Now, what if we got a negative ion, an anion, such as sulfur, where it's going to gain 2 electrons? So I'm always going to gain electrons to the outermost shell as well, because once again, that outermost shell has the least attraction to the nucleus. So I'm going to gain 2 electrons. Oopsie. I'm going to gain 2 electrons to the 3p orbitals. So 4 plus 2 makes 3p6. Lo and behold, also turning into the electron configuration for argon, because atoms strive to become as stable as a noble gas with 8 valence electrons in their outermost shell. So this electron configuration is exactly what I drew before. Same orbital diagram to be stable like a noble gas. If I want to draw an orbital diagram for an anion, I'm going to add electrons to the outermost shell. If I want to draw an orbital diagram for a cation, I subtract electrons from the outermost shell. Hopefully this helps you do the tasks on the next slide. I'll see you on Tuesday.